Hello dear friends. Today we are going to study about most important integration formulae that will be very useful. Diploma and degree engineering, BSc, BCom, BC and BBA. The first formula of integration of any constant term C with respect to x is equal to first put constant as it is and integration of dx is x. Here, integration of any constant k with respect to y. First put that constant k as it is and integration of dy is y. Here, integration of constant b with respect to z. So, b as it is, integration of dz is z. One more example, integration of 2 with respect to x. So, 2 as it is, integration of dx is x. Now, the next formula is integration of x raised to n with respect to x. Here, whatever the power given of the x is what n increase by 1 and put the same power in division. Here is n given, so n plus 1 and we will put the same in division. Then plus c is constant. Let's understand it through the example. Okay, integration of x cube with respect to x. Here is power given 3, so we will increase by 1, then put the same power in the division. Plus c is equal to x raised to 3 plus 1, that will be 4 upon 4 plus c constant. We will not write again and again all example the constant c. Okay, just we write in the main formula, so that will be easy for me to write. Then the next formula is, before that I want to give you one more example. Integration of x raised to 5 dx. It is the basic formula of integration that will be very useful. Here is power is given 5. Now increase by 1 and put the same power in the division term. So 5 plus 1 upon 5 plus 1. That will be x raised to 6 by 6. One more example. Integration of x raised to minus 3. So minus 3 plus 1. The same power in the division term. So that will be x raised to minus 2 upon minus 2. If you want to write in division, then x raised to minus 2 will become plus 2. So here x square plus. Now the next formula is integration of e raised to ax. Integration of e raised to x with respect to x is equal to, first of all, write down as it is e raised to ax. Then here the power is what given ax, then differentiate that power in division. Here a as it is and differentiation of x will be 1 with respect to x plus c. So finally e raised to x upon a plus c. Now let's understand it through the example. First one, integration of e raised to 2x with respect to x is equal to, first of all, write down e raised to 2x as it is according to the formula. Now differentiate the power in division. So differentiation of 2x is 2 as it is, x differentiation with respect to x is 1. So e raised to 2x upon 2 plus c. But I will not write again and again. Okay, so you can understand it. One more example, integration of e raised to minus kx with respect to x. So e raised to minus kx as it is, then differentiate and that power in division. So minus k as it is, and differentiation of x with respect to x is 1. So it will be finally, I am taking minus this out, so e raised to minus kx upon k. You may write e raised to minus kx in division, that will become plus e raised to kx if you want to write. Now our next formula number 4 is integration of e raised to x with respect to x is equal to, as it is, e raised to x. Then apply the log to the base and write in division. So log a term will be in division. Let's understand it through the example. Integration of 2 raised to x according to formula 2 raised to x upon log 2. Second example, integration of 5 raised to x with respect to x is equal to 5 raised to x upon log 5. Now, our next formula is formula number 5. Integration of f dash x upon f of x with respect to x is equal to, see, whenever any term is given in division and its differentiation is given in numerator, at that time integration of entire function will be log of division term. Once more, whenever two terms are given in division form, okay, and differentiation of division term is given into numerator, at that time integration of entire function will be log of division term. So here log of f of x. Here you may see here f of x and its differentiation is given into numerator f dash x plus c. Now let's understand it through the example. Integration of cos x upon sin x with respect to x is equal to, here you may see that differentiation of sin x, it is given in numerator. So according to formula, integration of entire term will be log of division term, and that is sin x. One more example, integration of two x plus 1 upon x square plus x. Here you may see division term is given x square plus x. Now differentiate it. Differentiation of x square is 2x and x is 1. That is given into numerator. So finally, integration of entire term will be log of division term, and that is x square plus x. Now our next formula is integration of sin ax with respect to x is equal to, we know very well that differentiation of sin x is plus cos x, but integration of sin x is minus cos x. Here integration of sin ax is equal to minus cos ax. Then here is angle is given ax. In differentiation, we differentiate the angle in multiplication form, but here x is angle that will be differentiated into division term. So a as it is, and differentiation of x with respect to x is 1. So finally minus cos ax upon a plus c constant. Now let's understand each two examples. Integration of sine 2x with respect to x is equal to integration of sine 2x is minus cos 2x. Then differentiation of angle 2x, that will be put into division while we are integrating sine. So 2 as it is, and x differentiation will become 1. So finally minus cos 2x by 2. One more example, integration of sin x is equal to integration of sin x, we know, minus cos x. Then here is angle is given x, its differentiation will put in division, so x differentiation is 1. So finally minus cos x. Now our next formula is integration of cos x. We know that differentiation of cos x is minus sin x, but integration of cos x is plus sin x. Here integration of cos ax is equal to sin x, and differentiation of angle, that will be put into division term. So here the angle is x, its differentiation ax differentiation 1, that we have put into division. So finally sin x upon a plus c. Now let's understand each example. Integration of cos 2x with respect to x is equal to integration of cos 2x is sin 2x. Now differentiate the angle into division. So angle is 2x, 2 as it is, then x differentiation is 1. So final answer will be sin 2x by 2. One more example, integration of cos x. Cos x integration is sin x. Then here is angle is x. Angle is x, its differentiation will be 1. So finally sin x. Now our next formula is integration of uv. Okay, when two terms are given in multiplication form and we want to find its whole integration, at that time this formula will be used. In this formula there are two terms u and v. So which one will be our u and which one will be our v? For understanding that, we are going to take one example like integration of x sin x. Take u whose second time, third time or fourth time differentiation will become 0, can be 0. Here we can see differentiation of sin x is cos sin x sin cos, continuously going on. But differentiation of x first time will be 1, then 0. So our u will be x and remaining will be our v. First of all, we will decide that, then put u as it is and integrate v is v1. It will be carry on plus, then minus, then again plus, then minus, then plus, then minus. Then use differentiate u dash and integrate v1 is v2. Differentiate u dash u double dash, integrate v2 v3. Plus minus plus, then here will be minus. Integrate v3 is v4, differentiate u double dash is u triple dash. It will be carry on up to 1 until we get differentiation of u term 0. Okay, I'm explain again. take u, both second time or third time differentiation can be 0. Okay, remaining will be of v term. So put u as it is, then differentiate u, that is u dash, then differentiate u dash, u triple dash, double dash, u double dash, differentiation u triple dash. V's integration v1, v1 integration v2, and v2's integration v3, and lastly v4. Here we have taken an example in which u is x and v is sin x. So according to the formula, put u as it is, u is x, then integrate v. V is what? Sin x. Sin x integration is minus cos x plus then minus. Now differentiate x. U dash means x differentiation is 1 with respect to x, minus as it is. Here is v2. v2 is what? v1 integration. Here v1 is minus cos x. So its integration minus as it is, and cos integration is sin x. Now just simplify it. Minus x cos x, but minus minus will become plus sin x. One more example, integration of x square e raised to 3x. Here differentiation of e raised to 3x, first time e raised to 3x. Again if we differentiate, then e raised to 3x, e raised to 3x, continuously going on. So that will be not our u. So x square differentiation, let's check it. X square first differentiation 2x, then 2, then 0. So x square will become our u, and e raised to 3x will be our v. So u, according to formula, u as it is, u is what? X square. v1 is what? Integration of v, e raised to 3x, integration is e raised to 3x upon 3, minus u dash, u's differentiation, u is x square, its differentiation will be 2x. Then v1 integration, here v1 is what? E raised to 3x upon 3. So e raised to 3x integration is e raised to 3x upon 3. There is already 3, so that we will put as it is. Okay, 3 is already there. We are integrating again, so again 3 will come, plus minus then plus. Now differentiate this, 2x differentiation 2 as it is, and x differentiation 1. Differentiate this, integrate second term, integrate this term. So integration of e raised to 3x is e raised to 3x upon 3. There are already 3. Okay, 3. So triple time 3. Now differentiate this. So 2's differentiation will become 0. So now the next all term will be 0. Now just you may simplify it. X square e raised to 3x by 3 minus 2x e raised to 3x, 3 3s are 9, plus 2 e raised to 3x, 3 3s are 9, 9 3s are 27. Now our next formula is integration of e raised to ax sin bx. Here two terms are given. So first thought arrives that we can we use the UV formula? Let's check it. For using UV formula, any one of the term, its differentiation will become 0. Let's check it. E raised to x differentiation, e raised to x, again e raised to x, again e raised to x. Not possible, 0. Same for the sin bx, cos bx differentiation sin bx. So we can't use this formula, what we have studied just. So there is special formula for e raised to x sin x, and the same for e raised to x cos bx. What is it? First of all, write down the e raised to ax as it is. Here the power of e is ax, and whatever the multiplication term of x, multiple of x is our a, that square will be here. Then inside angle is bx. Whatever the multiplication term of x is b, that will be squared here. What given? Sine bx. So we will write sine bx. And for remembering purpose, this formula sine bx integration, we are integrating now. So integration of sine bx is minus cos bx. Here two constant a and b. First put here and second here. Easy. First of all, write down the whatever the given e raised to x and e to the power ax, whatever the multiplication of x, that is a. Square it here. Then in angle is bx, whatever the multiplication term of x is what b, that will be square it here. Sin bx given, write down sin bx, and its integration we know minus cos bx. First put constant a here and then b here. Now let's understand each example. Integration of e raised to 2x sine 3x. Here compare the standard formula. A will be what? 2 and b will be what? 3. So now it's easy, just substitute the value of a and b. E raised to 2x as it is e raised to 2x. Then a square, a is what? 2 square. B square, b is what? 3 square. What is given here? Sine 3x, and its integration is minus cos 3x. For put constant a here is 2 and b is 3 here. That's done. Now we can do the next. E raised to 2x upon 2 square 4 plus 3 square 9. 4 plus 9, that will be 13. This term will be as it is. Okay, you can do by yourself. I'm taking one more example. Integration of e raised to kx into sin x. Here comparing with the standard formula, a will be what? X multiple is k. So our a will be k. And what will be b? Angle is nothing given. That means x. If there is no any term with x, so we can take 1, b as 1. So put e raised to kx as it is. A square, a is what? K square. B square, b is what? 1 square. Now sin x given, so sin x minus integration cos x. First put constant a is here and then b is here. Now you can do. Okay, just simplify it. 1 square is 1. Put this term as it is except 1 this. Now we are taking one more new formula. Instead of sin bx, if it is given cos bx, then what we have to do on that? Integration of e raised to x cos bx with respect to x is equal to, here the first term is the same, either maybe it given a sine or either maybe it given a cos, doesn't matter with that. E raised to x upon same a square plus b square. Now here what sine given, so we have written the sine. Here cos, so we'll write cos bx. Sine integration is minus cos, but cos integration is plus sine. For remembering purpose, I am doing that, telling that. First put constant a here, then b here. What we have done? Same what we have done in the e raised to x sine bx first term. Cos given, then write down the cos. Then integration of cos bx is plus sine bx. First put a here and b there. Now let's understand it through the example. We will take the same example what we have taken in e raised to x sine bx formula. Integration of e raised to 2x cos 3x. Same, a what? A will be our 2, whatever the power with x. Angle x with 3. Okay, so b will be 3. So now just substitute in the formula. E raised to 2x as it is a square. A is what? 2 square. B square. B is what? 3 square. Cos 3x given, so write down cos 3x, and its integration, cos 3x integration is sin 3x. First put constant a here, then b here. Now The next example, e raised to kx cos x with respect to x is equal to e raised to kx. Here, just as per previous one, a is what? K. B is what? Nothing. So we can take 1 because x, only x, whatever the given multiple of x shall be your b. So we can take 1. Okay. If it is 2s, then it will be the 2 as a b. So yeah, a square plus b square, a is what? Okay. B square what? 1 square. Now, here is what given? Cos x. Okay. We will write cos x. The integration of cos x is sin x. First put constant a here is k, b here is 1. Now you may simplify it. Same, just 1 square we will write 1 and no need to write this one. Okay, next step. Now, next formula is formula number 11. Integration of 1 upon x square plus a square with respect to x is equal to 1 upon a tan inverse x upon a plus c. Let's understand it through the example, like integration of 1 upon x square plus 4. Here you may see is a square form. Okay, here 4. So we have to convert 4 into a square form. So we know 4 is square of 2. So we can write x square plus 2 square. So now it is converted into this standard formula. So now we can apply the above formula. Compare with this. A is what? 2. So 1 upon 2. Tan inverse x upon a is what? 2. Now one more example. Integration of x square plus 9. Same, we have to do what we have done in the previous one. 9 we have to convert into a square form. So we can write 9 as 3 square. Now a will be 3 with comparing this. So 1 upon a is this. Tan inverse according to formula. Tan inverse x by a is what? 3. One more example. Integration of 1 upon x square plus 3. So we have to convert 3 as a e square form. So can we write 3 as under root 3 square? Yes, because square and under root will be cut, so we will get the original form 3. Now here our a will be under root 3. So 1 upon under root 3 tan inverse x upon a is under root 3. One more and last example, integration of 1 upon x square plus 1. Here we can write 1 as 1 square. So here a will be 1. So 1 upon a is 1. Tan inverse x upon a is 1. Now I think you have got this formula. Now we'll jump on next formula number 12. Instead of plus, if it is given minus a square at that time is equal to 1 upon 2a log x minus a upon x plus a. See, if it is minus instead of the plus, the formula will be changed entirely. Let's understand through the example 1 upon x square plus 4. Sorry, minus, because we have changed now x square minus 4. So we have to convert into a square from this 4. So 1 upon x square minus 2 square. Now we can apply the formula. 1 upon a is what here 2. So 1 upon 2a is 2. Log of x minus a is what? 2. But x plus a is what? 2. One more example. Integration of x square minus 9. So we have to convert 9 as a square form. So we can write 9 as a 3 square. Now we are applying the formula 1 upon 2a is what? 3. Log of x minus a is what? 3 upon x plus a is what? 3. Next example, integration of 1 upon x square minus 3. So can we write 3 as under root 3 square? Yeah. So a will be under root 3. So 1 upon 2a is under root 3. Log x minus a is what? Under root 3 upon x plus a is what? Under root 3. Now the last example, integration of 1 upon x square minus 1, in which we can write 1 as a 1 square. So a will be 1. 1 upon 2a is 1. Log of x minus a is 1 upon x plus a is 1. Now our last and final formula, formula number 13. Here we have seen x square is plus, x square is plus. But instead of plus x square, if it is minus, then. So there is different formula. Formula number 13. For that, if it is given like a square minus x square, what we are studying? X square minus a square. But instead of that, if it is given a square minus x square, then what we have to do? Very easy. We know. Can we take a minus out as a common out? Okay. So it will convert to x square minus a square. We have taken minus out common. Okay. Now we know the integration of this because we have studied now. 1 upon 2a log x minus a upon x plus a. 1 upon 2a log x minus a upon x plus a. Now according to the log property, if we interchange numerator and denominator of log term, minus will come out, and here is already minus, so that minus minus will become plus. So finally it will be x plus a upon x minus a. Okay, I'm writing down again this here. 1 upon a square minus x square. Integration is 1 upon 2a. We are interchanging numerator and denominator, so minus will come out. Here is already minus, so that minus minus will become plus. So x plus a upon x minus a. We have interchanged numerator and denominator of log term. Minus will come out, that minus minus will become plus. Let's take some examples, same what we have taken in previous one. Let's see. This is our main formula. Integration of 1 upon 4 minus x square. In previous one we have taken x square minus 4, x square minus 9, x square minus 3, x square minus 1. 4 we can write as 2 square. Okay, integrate it. So apply this formula. 1 upon 2a is what? 2 log x plus a. X plus a is what? 2 upon x minus a is what? 2. One more example. Integration of 9 minus x square is equal to 9 we can write as 3 square. So 1 upon 2a is what? 3. Log of x plus a is 3. X minus a is 3. And last example, integration of 3 minus x square with respect to x. So we can write 3 as under root 3 square minus x square. 1 upon 2a is what? Under root 3. log x plus a is what? Under root 3. X minus a is what? Under root 3. So we have studied 13 formula. Quickly, we are going to revise them one by one. We have studied first formula, integration of any constant term c with respect to x is cx. We have studied second formula, integration of x raised to n with respect to x is x raised to n plus 1 upon n plus 1 plus c. Then integration of e raised to x is equal to e raised to x upon a plus c. Then we have studied integration of a raised to x is equal to a raised to x upon log a. Then we have studied integration of f dash x upon f of x with respect to x is log of division term f of x. Then integration of sin ax with respect to x is minus cos ax upon a plus c. The integration of cos ax with respect to x is sin x upon a plus c. Then integration of uv is equal to uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4. Use differentiation u dash, use differentiation u double dash, v is integration v1, v1 integration v2, likewise that. Then integration of e raised to x sin bx is equal to e raised to x upon a square plus b square. Sin bx, its integration minus cos bx. First constant a here, b is here. Okay, here is minus b. Then we have studied integration of e raised to x cos bx. So e raised to x, same as per previous one, first term. It is cos bx given, so cos bx integration is plus sin bx. A is here, b is here. Then we have studied formula number 11, integration of 1 upon x square plus a square with respect to x is 1 upon a tan inverse x by a. If it is minus instead of plus in between x square and a square, then formula is 1 upon 2a log x minus a upon x plus a. And the last formula was 1 upon a square minus x square is equal to 1 upon 2a log x plus a upon x minus a. I hope you have understood well. Thank you. Thank you so much for the watching video.